Hello, everyone, and welcome to Astronomy Daily. I'm your host, Anna, and I'm thrilled to have you join us for another journey through the cosmos. Here, we dive into the latest, most fascinating discoveries and events shaping our understanding of the universe, all delivered with a friendly, accessible approach. Today, we'll start by exploring the largest black hole merger ever detected, an event so immense it's challenging our current theories. Then, we'll look at how private space flights are not just reaching orbit, but also paving the way for a dynamic commercial space economy. Plus, we'll uncover the secrets of an ancient lunar meteorite that's rewriting the moon's volcanic history. And finally, we'll discuss a rare opportunity to own a piece of the red planet. But you will need deep pockets. Stay tuned. Let's kick things off with a truly massive cosmic event. Astronomers have recently detected the largest black hole merger ever observed, an incredible event that has resulted in a new black hole approximately 225 times the mass of our Sun. This monumental collision, officially named GW231123, was picked up by the Ligo Gravitational Wave Observatories. Now, you might be wondering, what exactly are gravitational waves? These are ripples in the very fabric of space-time, first theorized by Albert Einstein in his general theory of relativity. They're caused by the most violent and energetic events in the cosmos, like the merging of two massive black holes. The first direct detection of these waves happened back in 2015 at the U.S. Laser Interferometer Gravitational Wave Observatory, or LIGO, marking a groundbreaking moment in astrophysics. Since then, gravitational wave observatories have truly opened a new window to the universe, detecting hundreds of black hole mergers. The LVK network of detectors, which is a collaboration between LIGO, the Virgo detector in Italy, and Kagra in Japan, has alone spotted about 300 such events in just the last 10 years. The newest and largest discovery, GW231123, was detected on November 23, 2023. Scientists poring over the data have determined that this event involved the collision of two individual black holes, each incredibly massive, ranging from 100 to 140 times the size of our Sun. To give you some perspective, the previous record holder for a black hole merger, known as GW190521, involved black holes with a combined mass of 140 times that of the Sun, so this new detection is a significant leap. The findings and their implications are being presented at major international conferences, highlighting just how important this discovery is. Mark Hannam, a member of the LVK collaboration from Cardiff University in Wales, notes that this is the most massive black hole binary we've observed through gravitational waves, and it presents a real challenge to our understanding of black hole formation. He explains that black holes of this immense size are not easily accounted for by standard stellar evolution models. One exciting possibility is that these colossal black holes actually formed through earlier sequential mergers of smaller black holes. Imagine a cosmic game of billiards, but with black holes. Gravitational wave observations like GW231123 are incredibly valuable because they allow astronomers to observe phenomena that truly test the limits of known physics. Charlie Hoy, another LVK member from the UK's University of Portsmouth, points out that the black holes appear to be spinning very rapidly, near the limit allowed by Einstein's theory of general relativity. This rapid spin makes the signal incredibly complex and difficult to model and interpret, serving as an excellent case study for pushing forward the development of theoretical tools. The scientific community recognizes that unraveling this intricate signal will take time. Gregorio Carullo from the University of Birmingham, UK, suggests it will take years for the community to fully unravel this intricate signal pattern and all its implications. While a black hole merger remains the most likely explanation, he hints that more complex scenarios could be the key to deciphering its unexpected features. Ultimately, as Dave Wrightsey, the executive director of LIGO, puts it, this observation once again demonstrates how gravitational waves are uniquely revealing the fundamental and exotic nature of black holes throughout the universe. It's truly a thrilling time to be studying the cosmos. Moving from the distant cosmos to our orbital neighborhood, we have a quick wrap-up to our coverage of the private AX4 mission to the International Space Station. Axiom Mission 4, the fourth NASA-supported private astronaut mission, has successfully completed its flight. This endeavor is a crucial part of NASA's strategy to foster a vibrant low Earth orbit economy and build operational knowledge for future commercial space stations. The four-person crew safely returned to Earth, splashing down off the coast of California aboard a SpaceX Dragon spacecraft. The international team included Peggy Whitson from Axiom Space, Shubhanshu Shukla from the Indian Space Research Organization, Sławomir Uznański-Wisniewski of Poland, and Tibor Kapu from Hungary. They spent about 2.5 weeks in space, having launched on June 25th from NASA's Kennedy Space Center and undocking on July 14th. During their time on the ISS, the crew conducted approximately 60 science experiments, along with educational outreach and commercial activities, returning valuable research, including NASA cargo, back to Earth. This mission truly highlighted global collaboration. It fulfilled a commitment by President Trump and Indian Prime Minister Narendra Modi to send the first ISRO astronaut to the station, involving 5 joint science investigations. It also carried the first astronauts from Poland and Hungary to stay aboard the space station. This successful private flight demonstrates NASA's vision for a strong economy off Earth. By purchasing services from commercial providers, NASA can meet its science and research objectives in microgravity more efficiently and at a lower cost. This strategic shift enables the agency to dedicate more resources and focus on its ambitious Artemis missions to the Moon in preparation for Mars, while low Earth orbit continues to serve as an essential training ground for these deep space explorations. Now let's turn our attention closer to home, to our celestial neighbor, the Moon. A remarkable discovery is rewriting what we thought we knew about its fiery past. A rare lunar meteorite found in Africa in 2023 is shedding new light on hidden volcanic processes that shaped the Moon long after its surface was believed to have cooled. This meteorite, officially named Northwest Africa 16286, is an incredible 2.35 billion years old. Its unique chemical signature has plugged a significant gap in our understanding of the Moon's volcanic history. Researchers from the University of Manchester unveiled their fascinating results at the Goldschmidt Conference in Prague, detailing how this ancient rock illuminates the Moon's evolving interior and the surprising longevity of its volcanic activity. By carefully measuring lead isotopes, the team determined that this particular rock solidified around 2.35 billion years ago. This period is especially interesting because we have almost no other samples from that specific time. What makes it even more extraordinary is its unusual geochemical fingerprint, which sets it apart from the base salts brought back by the Apollo, Luna, and Chang'e missions. This suggests it crystallized from deep source lava shortly after reaching the lunar surface. Dr. Joshua Snape, a research fellow at the University of Manchester, explained the immense scientific value of lunar meteorites. While samples from return missions are invaluable, they are limited to the immediate landing sites. Lunar meteorites, however, can be ejected by impact cratering from anywhere on the Moon's surface, offering a serendipitous glimpse into areas we couldn't otherwise explore without the massive expense of a space mission. This 311-gram meteorite is a type of lunar volcanic basalt called olivine ferric basalt, containing relatively large crystals of the mineral olivine, along with moderate levels of titanium and high levels of potassium. Beyond its unusual age, the study found that its lead isotope composition, a geochemical fingerprint, points to an origin in the Moon's interior with an unusually high uranium-to-lead ratio. These chemical clues suggest ongoing heat generation within the Moon, likely from radiogenic elements decaying and producing heat over an extended period. The age of the sample is particularly exciting because it effectively bridges an almost billion-year gap in lunar volcanic history. It's younger than the basalts collected by the Apollo, Luna, and Chang'e 6 missions, but older than the much younger rocks retrieved by China's Chang'e 5 mission. Its composition, combined with its age, indicates that volcanic activity continued on the Moon throughout this vast time span. This unique rock provides new constraints about when and how volcanic activity occurred on the Moon, guiding where future sample return missions might land. From ancient moon rocks, we now travel even further to another familiar neighbor, Mars. Soon, a unique opportunity will allow someone here on Earth to own a significant piece of the red planet, as Sotheby's prepares to auction off the largest known Martian meteorite on our world. This extraordinary specimen, officially designated NWA 16788, is anticipated to fetch up to $4 million at the upcoming auction in New York City. The rarity of such a find cannot be overstated. Out of more than 77,000 officially recognized meteorites discovered on Earth, only about 400, or roughly 0.6%, originate from Mars. NWA 16788 itself represents an impressive 6.5% of all Martian material currently known on our planet. This colossal chunk of Martian rock, weighing in at just over 54 pounds, was likely dislodged from Mars by an asteroid strike, sending it on an incredible journey. It traveled an astounding 140 million miles through space before making its dramatic landing in the Sahara Desert, where it was discovered in Niger's remote Agadez region in 2023. Cassandra Hatton, Sotheby's vice chairman of science and natural history, highlighted the sheer improbability of this journey, stating that the odds of this getting from there to here are astronomically small. More than just a collector's item, NWA 16788 is believed to be a relative newcomer to Earth, having fallen from outer space quite recently. This means it offers a pristine window into the Martian past. Hatton emphasizes its scientific significance, calling it not just a miraculous find, but a massive data set that can help us unlock the secrets of our neighbor, the Red Planet. Specimens like this from the Moon and Mars are considered among the greatest rarities on our planet, with Sotheby's noting that all known bits of both could fit into the cargo hold of a large SUV. It truly is a chance to hold a piece of another world in your hands. And to wrap up today, some late-breaking news from Australia's Gilmore Space. They've just posted the following message on X. We've scrubbed our July 16 launch window, now targeting the next approved opportunity, July 27. Why? Ops delayed us a day, and current upper wind forecasts have ruled out a safe launch for the rest of the week. Team will be back for 27 July. And that brings us to the end of another fascinating journey through the cosmos here on Astronomy Daily. Today, we've explored some truly incredible stories from the largest black hole merger ever detected, GW2 31123, which is pushing the limits of our understanding of these cosmic giants, to the successful return of the AX4 Mission 4 crew, showcasing the exciting future of commercial space travel and international collaboration on the International Space Station. We also delved into the mysteries of a 2.35 billion-year-old lunar meteorite found in Africa, which is rewriting the volcanic history of our moon. And finally, we looked at the incredible opportunity to own a piece of the Red Planet with the auction of NWA 16788, the largest Martian meteorite on Earth. Thank you for tuning in and joining me, Anna, on Astronomy Daily. If you want to dive deeper into these stories, sign up for our free daily newsletter or catch up on all our back episodes, visit our website at astronomydaily.io. You can also subscribe to the podcast on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts so you never miss an episode. Until next time, keep looking up.